Okay, a man and a woman walk away from the same location at the same time. So we start out with these two people co-located, crammed together at the origin. And let's see, he goes east at 2 meters per second. So he's going to end up over there someplace, and he's going to keep moving east as time goes by. And she goes south. So, whoops, I stretched instead of moving. She marches south like so, and he moves a bit faster. As they move, his distance to the east, I'm going to call X. I think that's probably reasonable. And her distance south, I'm going to call Y. And they're talking about the distance between them, and you can see that's going to be our hypotenuse. There's going to be a right triangle between these two people. I'll call that distance D. And as long as they stay on the corners of a right triangle, we can always say that x squared plus y squared equals d squared. So that takes care of the distances between them. And they want to talk about the rate at which the distance between them is changing, which is going to be d dt. So we knew a rate equation was coming, and now we need to create one. Differentiate this thing, and you get 2x dx plus, for this term, 2y dy equals 2d dd. As usual, all these terms are divisible by 2, and I'm just going to blip the 2's. And honestly, when I'm doing this for myself, I don't even write the 2's because I know that's going to happen. So here's our rate equation, and we want to divide it by t, of course. We want time rates. We want per second in this case. So there's our rate equation all filled out. And they're talking about 5 minutes later. So it's the first time they've tried this particular brand of devilry on us. Notice that our speeds are in meters per second, and here they are talking about minutes. So 5 minutes times 60 equals 300 seconds is the actual time we want to use. 5 minutes is the wrong unit. 300 seconds is better for us. Now that we know that, the guy is walking at 2 meters per second for 300 seconds, so the distance in the x direction should be 600 meters. dx dt is his speed, which is 2 meters per second. Positive, because x is increasing. She's going south at 1.8 meters per second. It's been 300 seconds. 300 times 1.8 means she's gone 540 meters. And her speed is 1.8. Also positive, because y is also getting bigger. So there's those two pieces. Big D, we don't have it, so we get to do a bit of a number crunch here to find big D. I'm going to switch colors for that. We get to do a side calculation. X squared plus y squared means, in this case, 600 squared plus 540 squared equals the total distance between them squared. And now we mash our calculators for a moment. I get 807. D is 807.2 meters for the straight line distance between them. That's our D. 807.2. And then we have d dt. So the rate of change of their distances is going to be this entire left-hand side divided by 807.2. So that comes out to 600 times 2 plus 540 times 1.8 equals divided by 807.2. And I get the distance rate of change is 2.69. They don't say how much precision they want. I'll go 2.69. That's all right. 2.69, sorry. And it's distance over time, so our units should be meters per second. And it's positive, which means the distance between them is increasing, which makes sense. Neither of them is chasing the other. They're moving apart in two different directions.